But let's focus on what are these greenhouse gases so that we can understand which are in our troposphere causing the warming of Earth. CO2, and I actually have that as my first one. Next. Nitrous oxide. Could it be that one? Nope. It's this one. Oh, forget it. Methane, nitrous oxide, water. What else? Ozone, CFCs.
Did you say carbon monoxide?
There's no carbon monoxide. So if you want to list them, because you're seeing them very clustered here. And when you're going to study, you want to have notes that are a little bit more visual, like Jeremy's. So you should make a list somewhere on this paper. CO2, CH4, what's that? Methane. H2O is water. CFCs, chlorofluorocarbons. Ozone is what?
O3.
O3, correct. And nitrous oxides, you could just put NOx. Okay? Talking yesterday about greenhouse gases, and what are the three gases that people consider topics of concern? And the answers are carbon dioxide, methane, and nitrous oxide. We worry about these because these are more prone to staying in the troposphere, not reacting with other things, okay? Water is the #1 heat trapping greenhouse gas. So it traps, I have a table that shows you, it's probably 100,000 times more heat than, let's say, carbon dioxide would. But water's constantly reacting or constantly changing states, so it's not something that just stays there. Methane doesn't react with many things or break apart. Carbon dioxide, same thing, and nitrous oxide. So in that case, that's why you consider those three the gases that we consider the topic of concern. CFC, also an extreme heat trapping gas, but it tends to find its way to the stratosphere. It doesn't stay in the troposphere. It somehow manages to find its way all the way up without breaking up.
What are CFCs?
Chlorofluorocarbons, which is the #1 ozone depleting molecule. All right, so since Industrial Revolution, so when we started to burn fossil fuels, obviously we increased levels of CO2, methane, nitrous oxides, because we mined, we retrieved things from underground that were naturally in the cycle and placed them into the cycle. And three main reasons. Farming, which was industrialized farming or increased farming needs to meet the world food production. Obviously what I just said, burning of fossil fuels. And what's this? Deforestation. How does deforestation increase levels of CO2, methane, or nitrous oxide?
When you can
Plants take in the CO2. So if we remove the plants, we're not necessarily, and this is important, so everybody look at me when I say this. When you remove forests, you're not necessarily increasing CO2. Explain that why. Explain why.
I thought that if you cut it down, the tree releases all the carbons that had accumulated in its sap. So essentially, everything the tree ever did in its life, removing the carbon dioxide, was for nothing.
I don't know if necessarily you're gonna, I think burning,
That's how I learned it.
okay, he has a point. If you cut down trees, the CO2 within the tree is going to be processed somewhere, but it's not necessarily gonna all be processed into the atmosphere.
Not immediately.
So give me a reason why, if I ask you that question, why would cutting down forests not increase CO2 levels? What's your answer?
It's not.
Emily?
Well, obviously, if you don't have any, if it's not alive, it can't take in CO2 when it's going through photosynthesis and it can't produce oxygen. But also, you brought up the point of burning, and that's burning of organic
Again,
matter.
listen to the question and answer the question. Why is cutting down forests not necessarily linked to the increase of CO2?
Because they don't provide CO2.
They don't produce CO2. If I ask you that question, you're going to answer that way. They remove it.
It's not
So what they're doing is not converting it and letting the levels stay there. That's really where they're trying to get, because I've seen a question like that. Now, if they ask you, How does cutting down forests increase levels of CO2? Brian's answer, your answer, all of those make sense.
Burning.
Okay? Burning deforestation. Number one greenhouse gas of concern is carbon dioxide. It is not the number one heat trapping gas. It's the gas that we are constantly worried about because the levels of CO2 have increased.
So that's
Here is a global warming chart, greenhouse gas chart, and it covers how long they linger in the atmosphere, which is what we were just talking about, and how water vapor is not even on here. But I know I go to another screen because water vapor doesn't linger. So I guess this one's more about lingering. So their lifetime in years, you see it right here.
How can hydrofluorocarbons have such a broad lifespan? Like it goes from either 1.4 years to 270.
I don't know what I'm doing. Concentration levels for the past 400,000 years of CO2 and methane, and look at temperature. Look at temperature and CO2, and I've actually done this before. I don't have the camera out in this, but if I take a picture of this and I kind of lay them,
Looks pretty similar.
they look very, 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 very similar. So this is where you start to ask yourself, did the increasing levels of CO2 cause temperatures to rise, or did the temperatures rise, which led to the increasing levels of CO2? And honestly, the answer is yes for both. Because we know that it's a positive feedback loop. So the debate that exists currently today, which a lot of people are trying very hard to disprove, is really CO2 or humans the reason for global warming? Or is it a natural cyclic cycle? There's no more debate if it's actually happening.
the next slide.
Okay, so I put it together. So I said I could actually take a picture and put them side by side, and there I did it. I used my little camera and I screenshot and I put them next to each other. And here is change in temperatures. What's happening since 1975 to now? Exponential temperature change, I would say. I have a movie that I want to show you, and it goes over this. So here are some facts. NOAA, who knows what NOAA is? It's climate. That's where you go to look at what are going to be, what's the tides are going to be like, what the seas are going to be like. You're going to go there. If you're going to follow a hurricane, don't go to Channel 7 or Channel 10. Go to NOAA. NOAA shows you the cone, just like Channel 10 does, but without all the words behind the possibilities of the cone. Channel 7, cone description is so you could go to Home Depot and buy wood and go buy natural gas for your barbecue and go all these things and water and leave everybody bare and go fill up your tank at every gas station and every container you have. NOAA tells you exactly what it is without all that fear tied to it. So I always go to NOAA. Thank God we I haven't needed to go there this year. Yeah, I know. We're beyond that point, aren't we? So, well, never say never, right? So anyways, global mean surface temperature warmed between 1 and 1.7 since 1850. Unfortunately, that statistic has to be known. So make yourself a little note because I didn't cover anything, but you have to know. Records indicate near level trends in temperatures from 1880 to 1910, a rise to 1945, a slight decline, but a rise to present. Remember, when asked the question, describe Earth's global average temperatures, your answer is what? Fluctuating, rising and falling, but overall, and a continuous increase, okay? Because even if you look at the increase from 1970 till today, which is significant, you still see a rise and fall. Global warming. What are they? I don't think I have any words here, so describe the pictures.
Oh, I saw that.
Like
that's right.
Yeah, extinction of some species is probably the only word I have there.
This already, I saw the glaciers falling apart.
Oh, biodiversity threat. Who could tell me what is the most threatened species to warming? So if you increase temperatures, you're lowering dissolved oxygen in the water. So automatically there's going to be a direct effect to them, to marine life. But even to them just being exposed to the rays, not UV rays, heat rays, okay? Temperature changes. What else? Look at the pictures, describe them. Let's go with the first one.
Wait,
Melting of ice caps.
What does that mean? Decrease of something, increase of others? Good comment.
Oh, that's a really good question. What increases?
Some of the like
Some parasites increase.
The ones we don't want.
Yeah.
Viruses, parasites,
They thrive in
insects.
the warm.
They thrive in warmer climates, and this is a big topic that hasn't even reached the textbooks yet. Of what, I mean, minimal, like 1 unit in your book, which I see in a newer edition being a bigger unit. Because we always talk about threats of species decline, but now we're realizing there's the other threat, which is the increase of species. Yeah. So we've got glaciers melting. What's the next one? Flooding. What's the third picture?
Extreme weather.
Extreme weather. Write that down because obviously you're not getting the words. What's the next picture?
Drought.
Drought. Yeah. Drought is extreme weather too, and so is flooding in that sense. But more specific, you got to think of water being a big topic.
Wait,
And-
is that money?
Money, economy, it affects the economy. You have to deal with all these issues.
So is flooding necessarily weather-based?
It can be.
It's
If you have extreme weather and you have extreme rainfall, could lead to flooding.
it's a result
Or
of
a
weather.
tsunami, but that has nothing to do with global warming, so.
It's a result of weather, but it's not considered weather because it's not in the troposphere. It's on the surface. It has to do
She's
with
gonna
weather.
be our key contributor to, because she's taking Ruggy's class. So we have this extra little benefit of Ruggy, a little piece of Ruggy here.
What is the picture on top
Yeah, I
of
should
That
switch
picture
it.
on top left,
Yeah.
glaciers,
The one in the middle with the.
flooding. Oh, the kid, what's the one in the middle of the kid?
Decrease of food.
Famine. Food production in general seriously affected. Crops are affected. Remember, you're gonna think the most affected species are always gonna be single-celled organisms, and then plants are next. Even though they're multicellular, they're the ones that take everything in for us. So this extra additions of chemicals or temperature changes is gonna affect them severely. And obviously us, I guess, of what's going on and is this really happening? 90 to 99% of these panelists agree that the atmosphere is warm. So in the past, let's say 50 years, according to this, because they got together around 2005, I guess, average temperatures increased about 0.74 degrees Celsius. So almost a full degree. Yeah. Annual greenhouse gas emissions was raised about 70%. So then you ask yourself, 99% or 90% of these scientists or panelists all agree that we've increased greenhouse gases by 70%. And then you're going to tell me, is there actually a debate on which came first? Past 50 years, Arctic temperature rising almost twice as fast as the rest of the Earth. When I show you pictures of Arctic rise, melting of glaciers, it's pretty impactful because they literally are graphing the border of the glacier per time period. So there's two ways to look at it. How much melted this year and how much melted faster each year. So normally the melting began in March, then they started to happen in February. Do you get what I'm saying? And those are not accurate facts, but I'm going to show you that. Prolonged droughts, and over the last 100 years, sea levels rose 10 to 20 centimeters.